To learn more about earning college credits with study hall courses, visit gostudyhall.com or click the link in the description. Philosophical question. If you talk to a computer all alone in the woods, does it understand? Do you? Okay, maybe that was nonsense, but interacting with a computer is important because when a computer can take in and respond to the information we give it, we get a whole new level of versatility. Programming is basically communicating with computers in a precise way. Very precise. No, more precise than that, extremely precise. We have to work with specific syntax, which feels like a bit of a foreign language, but with all of this effort, the computer can follow our code and give us the results. And there are lots of times when we need a computer to understand us so that it can do something. Like basically any program beyond the absolute simplest ones needs the computer to take the information we're giving it, store it, manipulate it, then give us something new and useful in return. That's essentially the magic of programming, and when we know how computers take an input and how to have a back and forth conversation with them, we're able to harness that magic. Hi, I'm Sabrina Cruz, and this is Study Hall, Code and Programming for Beginners. The simplest way we communicate with a computer is through text, and we can do this in several ways. To send messages to our programs, we use a terminal window. This is a space in a coding environment, or on its own, where we communicate with the computer and tell it what to do. Either way, we can type messages and instructions directly into our open terminal, and anything we type can be stored. In fact, when we type into the terminal and press enter, the key presses are added to what's called the standard input. In Java, the standard input is called System.in, and we can use it to collect user input in a program. That is, as long as we've instructed the computer to expect messages from us. In other words, to expect input. In programming languages, there are many ways for us to input data. Often these allow a program to pause while the user enters some information, like a number or word. That information is encoded with a method like ASCII, then stored, and then the program continues. ASCII maps letters, numbers, and symbols to numerical values that are then converted to binary, as we discussed in our episode on computer memory. In Java, one of the ways to input information is to use a scanner, which reads encoded standard input into a program. Think of the scanner like a little machine that translates human-readable input into machine-readable terms. Fortunately, it's also a little machine that we can customize. We can import a blueprint for building a scanner from the Java library. Just like a real-life library is a collection of books, a programming library is a collection of blueprints for different Java tools. And like all libraries, there are lots of cool and mysterious things inside of our Java library. So to find the blueprint we're looking for, we use a period between parts of our command. This is technically called the dot operator, and it tells the computer where to find specific things in the library. In this case, we want the scanner blueprint on the util shelf in the Java standard library. Then, to check out this blueprint from our library, we tell the computer to import it. Then we're ready to use the scanner blueprint to construct our own personalized scanner. To see this in action, let me introduce you to Ava here. She's an aspiring researcher who wants to explore housing inequality issues in her city for a school project. Ultimately, her goal is to create a map that shows information about apartments in her city. With this map, she can take a geographical look at housing and figure out if there are patterns in apartment sizes and rental prices. To get the information she wants to analyze, Ava has decided to collect survey data from people who rent apartments around the city. She'll need to store that data on her computer, then track and manipulate the information she collects. She also has to organize everything in a way that will be clear to her future self and anyone else who might want to join the project. That means she needs to communicate the information to the computer and tell it what to do with that data. But she also needs it to talk back to her. To accomplish this, she'll build a simple program that takes all kinds of user input and gives helpful messages along the way. Ava's work relies on getting information from survey participants about their living situation. So she needs to build a scanner that can help collect information like apartment size and location data from those participants. First, she tells the computer to pull up the scanner blueprint, like the one we checked out earlier. Then, Ava tells the computer what she's going to name that scanner, which is important so that she can understand her code in the future. Next, she tells the computer to build the scanner using the scanner constructor. Inside this snippet of code, Ava also tells the computer where to find the input she needs, which here will be the standard input. Now Ava has a scanner that can collect input, which means her program can be interactive. It's a little confusing because we can't actually see the scanner organizing our inputs, but it's there. We're also only going to focus on the parts of the program that deals with input. input. Ava will have to write more code to actually use each participant's data, which we covered in our episode on storing data. Right now, to work with all of her different inputs, Ava will use, or in programming terms, call, special scanner methods for each data type. Methods are mini programs that perform specific jobs for special types of code. In this case, they only work with a scanner. First, Ava wants to know the size of each apartment, so she'll ask survey participants for the dimensions of their apartments. Later, she'll use that data to calculate square footage. To collect each user's apartment dimensions, Ava needs to write code that handles numerical inputs. So first, she tells the computer to ask participants to enter their apartment's length as an integer and its width as a decimal. Next, she calls a method named nextInt that will store the first input to an integer variable called apartment length. Then she calls another method named nextDouble to store the second input to a double-type variable called apartment width. When Ava tests this code, the computer shows a message asking for apartment dimensions. She enters 20 feet for apartment length and 10.5 feet for apartment width, while pressing enter after each input to continue. Behind the scenes, pressing the enter key places a new line after the input value. A new line is a character that tells the computer to move to a new line. It basically signals to the computer, this ends the current input, get ready for the next thing. New lines belong to a group of characters called white spaces, which are invisible characters that usually separate words and lines. Conveniently, the methods that we've used ignored any white space characters at the beginning of the input, capture the numbers, and stop at the next white space. Once Ava has gathered input, she can tell the computer to multiply apartment length and apartment width to get the apartment area and print the answer. That way, it will recalculate every time there's new input. Now Ava's ready for the location part of the survey, which will collect the neighborhood names and apartment addresses of survey participants. That means that this part of Ava's program needs to handle strings of text. Similar to how she handled the numerical data, Ava prompts her participants to enter the name of their neighborhood. She uses the next method, which retrieves one word at a time to store this information to a string variable called apartment neighborhood. And when Ava tests this code by entering Soho and printing apartment neighborhood, everything works. The last thing Ava needs from her survey participants is their address. Ava prompts participants to enter their information, then stores it in a string variable called apartment address using yet another method, nextLine. Unlike the other methods, the nextLine method captures all characters, including white spaces, until it reaches a new line. But that can be tricky, and here's why. Ava tries entering the address 190 Spring Street, and then printing the apartment address variable. Intuitively, she expects to enter the neighborhood and see it printed, and then enter the address and see that printed as well. Unfortunately, like my 7th birthday party, this did not go the way that we hoped. The first step works fine, but then she sees the second message, enter your address, and then emptiness. Like my 7th birthday party. Let's figure out what went wrong. Not at my birthday party, the printing. Remember, the enter key places a new line after the input string. Well, Java's next method doesn't like that. Here's why. Standard input is a buffer, a holding space for a collection of information. Buffers use a first-in, first-out ordering system. Think of the buffer as a line at your local coffee shop. Characters get in line when the user types them and presses enter. When we call one of the next methods, characters are taken off the queue in the same order that they came in. Here's what happens at the coffee shop. Soho joins the queue with a new line character, which was added when Ava pressed enter. Then, Ava calls the next method, retrieves Soho from the coffee shop queue, and prints it. Soho exits the queue, but leaves the new line there all by itself. Rude! We said before that the nextLine method automatically stops when it reaches a new line. So Ava's nextLine method checks out the coffee shop, sees the new line, and leaves. Never bothered to look for more input because it just found the new line, assumed that was it, and called it a day. The empty line we saw in the output before was actually just the new line, the character that stayed in the buffer. The new line stuck in the buffer is blocking apartment address from storing the correct information. So here's how to fix this. All Ava needs to do is have her code remove the new line from the coffee shop queue and allow new characters in. So she adds another nextLine statement after apartment neighborhood gets printed. This method is called a dummy nextLine because it only exists to clean out the buffer and make room for new characters. Now when Ava calls another nextLine after the dummy, the scanner will take more input and she can print the address. Ava can finally store the key information she needs, and she can continue developing her program to collect additional pieces of information from survey participants, like how much rent they pay. After she's gathered the survey survey data, she can plot the info on a map. When she visualizes the data geographically, she'll be able to see where different kinds of apartments are located. Maybe she'll find that the only apartments near city parks are small with high rents, and that would limit who has access to green space. Or maybe she'll find that low-rent apartments are mostly located in the city's food deserts, and that would mean that there's a disparity in how easy it is to make healthy meals. Insights like these all start with gathering information, and the skill of collecting user input empowers Ava to better understand her community, combining her two passions, programming and social justice research. Developing the ability to communicate with computers is a key milestone in our programming journey. Instead of just writing a program and getting output after a computer has run every line of code, we can now give the computer input and get output while the computer is running our program. It's like we've gone from pen pals waiting for replies to chatty friends talking on the phone, having a conversation. When we can communicate with computers in more of a back and forth of input and output, our programs can become more powerful. Whether with people or computers, conversations give us a chance to work together more closely and solve problems. If you're enjoying study hall code and programming for beginners and are interested in taking an online course and earning college credit, check out gostudyhall.com or click on the button to learn more. Thanks for watching, and see you next time.